Okay, our lesson today is to be able to approximate square roots of numbers that are not rational numbers. A rational number is a number that can be written as the ratio of two integers. An irrational number cannot be written as the ratio of two integers. The square root of any whole number that is not a perfect square is irrational. The cube root of any integer that is not a perfect cube is irrational. The decimal form of an irrational number neither terminates nor repeats. Rational numbers and irrational numbers together form the set of real numbers. You have some examples here. When we want to classify numbers as rational or irrational, the square root of 12 is irrational because it's the square root of a number that is not a perfect square number. We have the opposite of 25 hundredths that repeats. That is a rational number. Any repeating decimal can be written as a fraction of two integers. The next example is the opposite of the square root of 9. That is a rational number because the square root of 9 is a perfect square number. We could take the square root of a perfect square number. The square root of 9 is 3. 72 over 4, that is a rational number because it is written as a fraction, or it can be written as a fraction of two integers, and 72 over 4 is equal to 18. Pi is an example of an irrational number. The decimal form of pi neither terminates nor repeats. So when we look at these examples here, right, this first example, we see that we have a decimal that does not terminate nor does it repeat. And if the decimal does not terminate or repeat, that is an irrational number. Our next example is the square root of a number that is a perfect square number. 14 times 14 is 96. So if we want the opposite of the square root of 196, it's going to be negative 14. Here we're being asked for the cube root of a number that is not a perfect cube. So this would be an irrational number. All right, we continue. We want to classify as rational or irrational. A rational number is a number whose decimal digits do not terminate or repeat. We look at this first example. This decimal does not terminate or repeat, so that's an example of an irrational number. This next example, we see that we have a repeating decimal, and any decimal that repeats, that is going to be rational. 1 2/9 can be written as a fraction of two integers, so that is another rational number, any number that can be written as a fraction of two integers. The square root of 5, that's the square root of a number that is not a perfect square, that is going to be irrational. The next example, we have a repeating decimal, as shown with the line over the 6. When we have a repeating decimal, any repeating decimal can be written as a fraction of two integers. So that is a rational number. Our next example, we have the square root of 7. 7 is not a perfect square number, so the square root of numbers that are not perfect square numbers, that is irrational. Our next example, we have a decimal that terminates. Any decimal that terminates or repeats, that is going to be a rational number, because any decimal that terminates or repeats, we can write as a fraction of two integers. So now we have our first example where we want to approximate a square root. So we have the square root of 71, and we wish to approximate the square root of 71. In order to approximate the square root of 71, right, we start by writing the square root of 71 using the square root symbol. We then want to find the two perfect squares that are directly less than and greater than 71? Well, the perfect square that is directly less than 71, that is 64. 64 is the product of 8 times 8. So we know the exact square root of 64. We know that that is going to be 8. The square root that is directly greater than 71, well, if 8 times 8 is 64, that means that 9 times 9, which is 81, right? The square root of 81 is 9. That'd be the next square root. So we find the square roots that are directly less than and greater than the square root that we're wishing to approximate. Next, we have to look at our differences. The difference between 71 and 64 is 7. The difference between 71 and 81 is 10. When we add 7 and 10, we get the difference between 64 and 81. That's going to be 17. And what we do is we use this fraction, the difference between 64 and 71, and the difference between 64 and 81. We're essentially saying the following, that the square root of 71 is 7/17 away from the square root of 81. Well, we know that the square root of 81 is 9, and the square root of 64 is 8. So the square root of 71 is in between 8 and 9, meaning that it's greater than 8 and less than 9. Well, if we see that the square root of 71 is 7 away from 64 and 10 away from 81, it means that the square root of 71 is closer to 9 than it is to 8. Well, anyway, we need that, let's see, the square root of, we need to write 8 point something, right? Because the square root of 71 is going to be equal to 8 point something. So we have to find that something. So we take our 7/17 and we do a little long division. We divide 17 into 7, and we are going to approximate that decimal. Okay? Well, let's do that little long division. 17 doesn't go in the 7, but 17 goes in the 7. Let's see. 17 is 34, 44, that's 51, 61, right, that should be 5. 5 times 7 is 35, carry the 3. 5 times 1 is 5, and 3 is 8. Oh, too big. Right, so it's going to be a 4. Let's redo that. It's going to go 4 times. 4 times 7 is 28. Carry the 2. 4 times 1 is 4, and 2 is 6. It's going to give us 2. Bring down the 0. 17 goes into 20 one time. So we get about 4/10, which means that an approximation for the square root of 71 is going to be about 8.4. Alright? And that's how we would approximate the square root of 71. We use the ratio that we create by finding the differences here. Alright, let's take a look at some examples down here. Alright, extend the page a bit. And let's create some space. Alright, I just want to create a little space here. Alright, so we have some room to do the problems. Okay, so let's start with the square root of 8. We want to approximate the square root of 8. Well, we know that the square root of 8 is in between the perfect squares of 4 and 9. The square root of 4 we know is 2. The square root of 9 we know is 3. So the square root of 8 we know is 2 point something. We have to figure out that something. Well, we look at the differences here. The difference between 8 and 4 is 4. The difference from 8 and 1, that's 1. So the difference here is 5. So we use the fraction 4/5. Right? Well, 4/5, we know that is 8/10. Right? So the approximation for the square root of 8 is going to be about 2.8 to the nearest tenth. let's try the opposite of the square root of 13. Square root of 13 is in between what perfect squares? The square root of 9 and the square root of 16. Square root of 9, we know that that's 3. Square root of 16, we know that that's 4. We know the difference here between 9 and 13 is 4. Difference here between 13 and 16 is 3, so that difference is 7. So we take the fraction of 4 over 7, right? 4 over 7, and we do a little long division, right? 7 into 4. 7 goes into 40 5 times. 5 times 7 is 35. Subtracting it 5, bring down the 0. 7 goes in there about 7 times, right? So that means this approximation for the square root of 13 would be 3.6, right? Because this 5 here would round up to a 6. So the approximation for the square root of 13 would be 3.6. All right, next one. Oh, but we don't forget the opposite of the square root of 13, so that would be, boop, negative 3.6. I don't want to forget that. Square root of 24, we know falls between the perfect squares of, let's see, 16 is a perfect square number. 25 is a perfect square number. Square root of 16 we know is 4. Square root of 25 we know is 5. Well, we look at the differences here. The difference between these two numbers is 8. The difference between that is 1, so that's 9. We know from memorization, 8/9 is equal to 0.8 repeating, right? So when we approximate the square root of 24, it's going to be in between 4 and 5, which means it's going to be 4 point something, and because we have the repeating 8, that's going to be 4.9. But we want the opposite of that, right? Don't forget the negative sign. So we're going to have negative 4.9 for the approximation of the opposite of the square root of 24. All right, square root of 110. All right, 110. 110 is in between the square roots of, let's see, 100 and then 121. The square root of 100, we know that that is 10. The square root of 121 we know is 11. We look at our differences here. Difference here is 10. Difference here is 11. Right, so that's going to be 21. So we have the fraction of 10 over 21. Right, and 10 over 21, we can approximate that, right, at 0.5, right? We know that. So our approximation for the square root of 110 would be 10.5, right? Because we know it has to be in between these two integers, 10 and 11, right? And 110 is almost right directly in the middle of 110 and 121. That's why we can approximate that at 10.5, right? And of course, use your calculator to check these, and you'd see that they are accurate to the nearest 10. Okay, now this page is for you guys to do a little practice. And yeah, I would suggest stopping the tape and practicing on your own just so that you can get the hang of it, and then maybe restarting the video to kind of see, you know, if you did it correctly. All right, but we'll do these 5 examples here. All right, the square root of 28. Oops, square root of 28 is in between which perfect squares? Square root of 28 is in between the square root of 25 and the square root of 36. Square root of 25 we know is 5. The square root of 36 we know is 6. We are what? 3 away here. Here we are 8 away. So that's going to be 11. So we're going to use the fraction 3/11. Right? 3/11 is about, right, if we do our long division, well, 3/11 is about 0.3 because 3/10 is 0.3. 3, right? So it's about, 3/11 is about 0.3. So we're going to approximate this at 5.3. right? Because it is in between 5 and 6. And if you did your long division, right, and we have space for that, I'll squeeze it in here, right, 11 into 3, right, you would see 11 goes in there 2 times. 2 times 11 is 22. Subtract, you get 8. Bring down the 0. Right? 7 times 11, 77. So we see it is going to be around 2 3/10. That's why we get 5 and 3/10. Okay? Try our next one. 38. The square root of 38 is in between the perfect squares of the square root of 36 and the square root of, that's going to be 49. We know that that's 6. We know that that's 7. So the square root of 38 will be in between 6 and 7. Let's see, we are 2 away here. Here we're 11 away. So that's going to be 13. So we need to find the fraction of 2 over 13. All right, oops, 2 over 13, because we're using those two numbers. When we divide 13 into 2, do a little long division. It ain't gonna kill you. All right, 13 doesn't go in there, it goes in one time. All right, we subtract, we get 7, bring down the 0. 13 goes into 7, what's that, 5 times? 5 times 13 is 65. 0.15, that's gonna be approximately, right, 2/10. So we're gonna have 6 and 2/10 for our approximation for the square root of 38. Our next one, square root of 95 is in between the perfect squares of what, 81 and 100. Square root of 81 is 9. Square root of 100 is 10. We are, what's that, 14 away? And here is 5 away, so the difference here is 19. So we have to do a little long division. We need to find the fraction for 14 over 19, right? We're using those differences there. 14 over 19, let's see, 19 goes into 14. Decimal point. Let's see, 20 into 140 is going to go 7 times. 7 times 19 is 133. We subtract, we get 7. Bring down the 0, and that's only going to be 3 times. So that's approximately 0.7. So our approximation, the square root of 95 is in between 9 and 10. So it's going to be about 9.7 to the nearest 10th for our approximation for the square root of 95. All right, let's try a couple more. The opposite of the square root of 105, right, that's going to be in between the square roots of 100 and 121. Again, let's see, 100 and 121, that's going to be 5 away, and this is 16 away, so it's going to be 21. 5 over 21, right, that's going to be 10, that's going to be 11, so we know we're going to have 10 point something, so we have to divide, right, 5 by 21 to find the approximation. So we'll do that down here, 21 into 5, long division, that's going to go what, 2 times, that's 42. Subtract to get 8, bring down the 0, that's going to be what, 4 times approximately. I mean, it's 3, but it's going to be close to 4, but nonetheless that's going to still be to the 10.2, and we want the opposite of that for this problem, so negative 10.2 would be our approximation. Our last example, let me just slide this over a little bit. Right, slide this over a little bit. All right, our last example. All right, let's play around here. 54, that's in between what? This perfect square is of 49. That's 7 times 7, and then 8 times 8 is 64. That's going to be 7, that's going to be 8. So we are how many away here? That looks like that's 5. This is 10, so that's 15. Hey, that's a fraction we know. 5 over 15, we know that that is 1/3, which we know is 0.3. Repeating. So we're going to have 7.3 for our approximation but we need the opposite of that. Right, got to be careful when we have the negative or the opposite of the square root. All right, hopefully those are some good examples for you. A few more things in the lesson. We want to be able to use this strategy now to be able to compare numbers. Right? We want to be able to compare the square root of 5 with 2 2/3. And we're being asked which of these numbers is greater. Well, in order to determine which is greater, we need to know their decimal values so we can compare. Okay, well, let's start with the square root of 5. Right? Square root of 5 is in between the perfect squares of 4 and 9, so that's going to be 2, and that's going to be 3. That's going to be what? 1, 4, and that's 5. 1/5, so we know that 1/5, right, is the fraction we're using. We know that that's 0.2. So the square root of 5, we would approximate at 2.2. So we know 2 2/3 is about 2.7. So we're comparing 2.2 with 2.7. Well, we know 2.7 is greater, so we would have the square root of 5 is less than 2 2/3. In order to accurately answer the question, we have to find the decimal values for each. So we have some examples to do down here. Right, so let's do a few. The square root of 220 and 14 3/4. Well, the square root of 220, we'd have to do that down here, so I'll squeeze problem 13 down here. We have to find the square root of 220 because we know 14 3/4. We know that that's 14.75 because we know the fraction 3/4 is 0.75. So we need to know what's the approximation for the square root of 220. We know the perfect squares, 196, that's 14 times 14, and we know that the square root of 225 is 15 times 15, so we know that the square root of 220 is 14 point something. Let's find the something. We look at our differences here. The difference between 220 and 196, that's 24. That's 5, so this is going to be 29. Well, 24 over 29 is approximately 5/6, which we know is 0.8, right? 5/6 is 0.83. So, right, we know that that's going to be a little bit greater. Right? It's about 14.8. So that's going to be greater than the 14.75. So we know that when we're comparing for problem 13, the square root of 220 is going to be greater than 14 3/4. All right, but we have to find that approximation. All right, if we're doing problem 14, all right, if we do this, let's see. Well, the square root of 135, we know that 12 times 12 is 144, so this is negative 11 point something, right? This is negative 12 point something because we know 11 times 11 is 121, 12 times 12 is 144, right? So that's less than 144. That's more than 144, so this is going to be 12 point something. That's a negative 11 point something. Now when we're comparing, the more negative something is, the less that something is. The more negative, the less it is, which would mean that the opposite of the square root of 135 is going to be greater than the opposite of the square root of 145, right? Just using a little number sense for problem 14. Okay? Problem 16, we kind of do the same thing, right? It's a little easier, right? We'll get to 15 in a minute. But problem 16, the square root of 1 over 4, 1 is a perfect square number and so is 4, so that's going to be negative, right, 1 over 2, right? because the square root of 4 is 2 and the square root of 1 is 1. So the opposite of 1/2 or negative 1/2, that is the same as negative, right, 0.5. And once again, we said the more negative something is, the less that it is. So because we know the more negative something is, the smaller it is, right? Which means then that, let's see, that would mean then that the negative 0.25 is actually going to be greater than the negative square root of 1 over 4. All right, now let's do 15. I'm going to squeeze 15 down here. What are we going to do with 15? Well, 7 over 64, how are we going to do that? Well, the square root of 7 over 64 is about, let's see, 7 over 64, we're going to have to divide that. So let's do that. 7 over 64, when we divide 64 into 7, right, 64 into 7, right, that's going to go, right, that's going to be about 0.1. So we want to compare the square root of, let's see, 0.1. That is going to be less than 3/8, because 3/8 we know is 3.75. So that the square root of that has to be less than 3/8, which would be 0.375. So this is going to be less. Okay, let's write that. That's 3/8. So that's going to be less than. All right. Alrighty. I think, let's see, I think that should be enough examples, right, for you guys to be able to do what you need to do. So I hope that that's been helpful, and we'll see you soon.